Hello, everyone, and welcome to the latest episode of Scrubbing the Skies, the webinar series of the Institute for Carbon Removal, Law and Policy at American University. I'm Wil Burns, and I'm one of the founding co-directors of the Institute, as well as a visiting professor at Northwestern University. Many of the CDR processes that are receiving substantial attention now ultimately require sequestration of the carbon. And there are a host of questions in this context in terms of cost, permanence, and safety. My guests today are engaged in one such process for storage, which is often termed carbon mineralization. Moreover, they're exploring the viability of this option in an area where the nascent field of CDR is even more nascent in many ways, the Global South, making this an interesting case study of how carbon removal might play a role in climate policy and economic development in countries such as Kenya, which is where we'll focus today. So I'd like to welcome our guests to the show and briefly introduce each one of them. Our first guest is James Mwangi, who is co-founder of the Climate Action Platform Africa. James holds a degree in economics from Harvard University and is a 2009 Archbishop Tutu Leadership Fellow of the African Leadership Institute. And our other speaker will be Claire Nelson, who is co-founder and chief science officer of Cella Mineral Storage, as well as a postdoctoral research scientist in the marine large programs at Lamont Doherty Earth Observatory at the Columbia University Climate School. We will begin with interventions by both James and Claire, and then we'll move to a few moderated questions, and finally we'll move to audience questions. So feel free to begin to populate the Q&A box as we proceed with the presentations. And with that, I will turn over the floor to James.
I think, Claire, you were to go first? Or was I? You may be on mute. Still on mute.
Sorry. I was just saying I'll let you go first and talk a little bit about just the general opportunity in Kenya, and then I'll come in with more details on
Fantastic.
Need for storage.
Thank you. I'll happy to do that. So, and thank you, Wil, for the opportunity and for the chance to be part of this conversation. My own entry point into this conversation is somewhat unusual. I think a lot of conversation about climate in the Global South proceeds primarily from the question of climate justice, equity, and the impacts of climate change caused by industrial emissions elsewhere in the world, and the impacts on the Global South. My own entry point, though, has been the question of climate action, the massive industries that the world will need to build in order to avert climate disaster, and the particular advantages that countries in the Global South may have in some of these critical industries of the future. In other words, how do we move from thinking about the work of repairing our climate as a grudge purchase, a task that someone must do and whoever made the mess must clean it up, and move instead to saying whoever made the mess should pay for cleaning it up, but whoever has the assets and the resources to do it best should actually build an economy around that activity. Now, when most people think about Africa writ large, Kenya in particular, you think about a growing population, the impacts of climate change, commodity economies, and so on. What we realized is the combination of a large and growing dynamic labor force, probably the world's largest across sub-Saharan Africa by 2050, combined with the natural resources and land that the continent has. It's the one place in the world where you have a large population coincident with actually fairly large amounts of untapped and underutilized land, as well as a superabundance of renewable energy potential. This is more than 1,000 times current energy demand in renewable energy potential. Make sub-Saharan Africa and places like Kenya in particular potentially really exciting frontiers for the fight towards decarbonization. And nowhere does this become more evident than when you think about technologies such as direct air capture with long-term sequestration through mineralization. Very often when people think about the role of Africa in this journey, we think about the rainforests, maybe the farmlands, maybe the mangroves. But it turns out that if you think about the critical enablers of large-scale direct air capture, of scrubbing the skies using technology, well, what do you need? You need lots of green energy without a competing decarbonization use, because if you're using high emissions energy to pull CO2 out of the air, you're taking 2 steps forward and 1 step back. And that actually applies even if you're using renewable or green energy in countries that do have emitting sources. You should use that energy to avoid the emissions in the first place. And so you're actually looking for places where you have massive runway in terms of lots of renewable energy potential, but no decarbonizing use. And that then points you towards Africa, where per capita emissions are still the lowest in the world. And so there's not that much to decarbonize, and yet there's a lot of this renewable energy. And indeed, as you'll hear from Claire, a lot of the other enabling resources to drive this industry. Why does it matter? This is not a particularly job-intensive part of the overall fight against climate change, but by unlocking the economics of energy system build-out, by providing a base use case for surplus renewable energy, it could allow for countries that simply haven't been able to develop their natural advantages of renewable energy hubs to actually underwrite that, using this as the kind of buyer of last resort, if you will. And we can see the power of these types of use cases, whether it's this or some of the other technologies out there, as a way to actually lower the cost of energy and equip this labor force with both energy and the raw materials that they need to be a hub for new green industrialization for the planet. So that's the vision that we have of the Climate Action Platform Africa, and it's one that we've been really excited to encounter Claire and the team at Cella, who bring a level of technical rigor too. And so Claire, I'll turn it over to you to talk specifically about the opportunity that the Kenyan Rift Valley, with its geothermal asset and its renewable power, as well as the underlying geology, offers as a potential hub for this industry.
Thank you so much for that background. And I guess I'll start here by, I think most of us in this webinar are probably familiar with direct air capture. So I'm just going to specifically talk about engineered removals, although James did mention the opportunity for nature-based removals. I'm going to focus on engineered removals, specifically direct air capture and CO2 storage. So yeah, direct air capture is an extremely energy intensive process at the moment. And although there's a lot of technical innovations happening right now that are probably going to lower the energy demand a bit, we don't anticipate it to be a get out of jail free card, meaning there are important trade-offs in terms of co-locating these technologies, like James said, in places where there are plentiful renewables, but also, quite importantly, the renewable build out to scale these technologies can't otherwise be used to displace fossil fuel dependence. So Kenya is unique in that 92% of its energy is renewable at the moment, and that's projected to get to 100 in the next couple years. And so about half of that 92% is from geothermal energy. So I showed on the first slide some photos of geothermal as well as wind projects in Kenya, and there's also a lot of solar power, but really Kenya is a global leader in geothermal energy. It's the 8th largest geothermal industry in the world, has a bigger geothermal industry than even Iceland or other places we're more familiar with associating with geothermal. And on the top right, it's a picture of the Olkaria geothermal power plant, which is estimated to be the largest geothermal resource in the world. It has about 2,000 megawatts potential just in that one site alone. So Currently, the installed capacity of geothermal in Kenya is close to 900 megawatts of electricity, and the estimated untapped potential is about 10,000 megawatts. So just to put that into perspective, back to this slide here, Kenya has enough excess electric energy potential from geothermal alone to power a 200 million ton per year DAC plant. And this is using solid sorbent DAC, which is the one on the right, the more energy intensive one, which takes about 2,000 to 2,500 kilowatt hours per ton of CO2. And the reason that Kenya is particularly interesting in terms of solid sorbent DAC technology is that there's a ton of waste heat associated with geothermal energy production that's currently not being monetized to its maximum potential in Kenya, because there isn't a huge demand for municipal heat and hot water like there is in Europe, for example. So there's this opportunity for geothermal power companies to not only have large-scale industrial demand for their electric energy, but also to monetize the waste heat and steam associated with geothermal energy production, making it a very attractive place for direct air capture companies to come in and scale up their technologies. So currently, we all know direct air capture is proliferating really rapidly, but there's this problem in specifically the voluntary removals market, which is that demand for high quality removals currently outstrips supply by orders of magnitude. And embedded within this is this problem associated with geologic storage. It's a major bottleneck to scaling these technologies because DAC companies currently outnumber storage companies like 10 to 1. And this problem is projected to actually be consistent despite the scale up plans of many different carbon capture and storage technologies. So this figure shows operational capture and storage, and as well as planned capture and storage and development. So right now we see that with this light green bar on the bottom, there's actually about 40 million ton per year capacity of operational storage. But what most people don't realize is that 75% of that is for enhanced oil recovery. Very small amounts of storage exist for pure storage, for carbon capture and storage. And so if we take into account the fact that a lot of places that have traditional kind of sedimentary basin storage capacity like the US, that storage capacity is most likely going to be probably used for point source capture and storage, or CCS. But when we think about CDR, the storage capacity is even smaller. It's a tiny sliver at the bottom of this graph. So planned capture and storage projects outpace what we need for decades to come. So if we look to the future, the dark blue bar is planned capture projects, whereas storage is the green bar that still lags behind. So we really need new technology to scale storage in places that have this opportunity to put CDR, as well as just globally. There's a storage problem where it lags behind what we need. So at Cella, we're developing carbon mineralization in basalts. So the Kenyan Rift is this top left figure shows. The East African Rift is one of the largest volcanic provinces in the world, and there's tons and tons of basalt and importantly collocated with this renewable energy. So just glancing at the map, we can see how big of a resource there is here. And there have been some preliminary assessments of capacity done by collaborators at University of Nairobi and Technical University of Kenya, assessing the storage capacity specifically for mineralization. So we're working on developing a new technology for carbon storage in basalt that is similar to what's been already demonstrated. So we know it works and we know it's safe. But specifically at Cella, we're coming up with novel injection technologies to increase per well capacity, cut water demand, and therefore lower cost. So something that's interesting in Kenya specifically is that a lot of the water resources, both groundwater and lake water, are non-potable saline water. So they're not going to be used for agriculture and for drinking water. So even though some of us may think of Kenya as a very dry country in general, there's actually huge amounts of water resources that can be used for mineralization technologies and for CDR specifically. So just I'll close out in a few minutes and leave time for questions, but just preliminary, our business model at Cella is to co-locate with renewable energy sources, specifically geothermal, and partner with direct air capture companies in which they will be our customers, and we will provide mineralization as a service, and the direct air capture companies will sell offsets to the voluntary market. So there's obviously a lot of interest and benefits in this from the energy providers because they're looking for large-scale industrial demand to anchor their energy production, meaning that it's really incentivized for them to host direct air capture on their concession sites to guarantee that they have customers to buy their electricity and waste heat for decades to come. But the first piece of this, of course, is to do a pilot and prove out the geologic storage potential of Kenya, in which we anticipate that a lot of DAC companies will then really want to co-locate here because of the fact that there just aren't very many storage projects in development for CDR. So, yeah, just in conclusion, there's a lot of global interest in Kenya that extends beyond our work at Cella, hugely in large part thanks to James and the work that he's done to just really pioneer interest in this space. We have a pipeline of DAC customers that are really interested in coming and deploying in Kenya and making it a priority for their global expansion plans, as well as a network of academic support and a government and ecosystem support of different actors that are interested in partnering and really realizing this opportunity. And finally, I'll just end with the fact that we at Cella have partnered up with Frontier Climate, and they have purchased the first ever engineered carbon removals in the continent of Africa and in the entire global south. So we're really grateful to Frontier because we have a customer to buy the removals once we start generating them. And it's just really kind of underlined the global interest in this opportunity. And maybe I'll just make a quick note about the policy support coming from the government of Kenya from the top down is that there's a workshop actually next week hosted by the Global Carbon Removal Partnership in conjunction with the President's Office of Kenya, really trying to strategize how can the government shape policy and regulations to make it very favorable for DAC companies to deploy here. Like places in the US that have billions of dollars to incentivize DAC to deploy here, really kind of make it difficult for DAC companies to consider deploying elsewhere. But obviously there's a lot of opportunity here, and it would be a really meaningful place to deploy and kind of scale this opportunity. And so yeah, there's a lot of policy support coming from the top down to try to figure out ways to make that happen and to streamline this process to make Kenya a very easy place to do this and a very a place to do it quickly. So yeah, I guess I'll just end with that. And then if James, you have anything to add, otherwise we can take questions.
I think that was outstanding, Claire. I look forward to taking on some really interesting questions already starting to show up in the chat. But Will, back to you to guide us through how to tackle those.
All right, thank you very much, James and Claire. So I'll just ask a couple of preliminary questions and get us to the audience questions, which are coming in a flurry. So that's good. Just a couple of questions about the economics and technical questions, Claire, of this process. So first of all, what's your estimated cost per ton for this process at this point?
Yeah, everyone loves to ask about costs. So currently in the short term, we're projected to be kind of similar costs to other technologies doing carbon storage in basalt, which is around $40 per ton for our first of its kind deployment. But our scale up plans and our projected reductions in unit economics get us to about $10 a ton. And so we would be cost competitive with kind of traditional sedimentary basin carbon storage, which most people think of as really quite cheap. I think there's this kind of thought, I guess, in the carbon removal and carbon capture and storage space that mineralization is really expensive compared to kind of traditional types of carbon storage, which is actually not true. They're quite cost competitive with each other, and mineralization is actually much more favorable when you take into account the long-term cost of monitoring as well as the liability costs associated with traditional saline formation storage.
Great, thanks for that. Another question is, it seems like your initial business model is premised on direct air capture companies populating this region and then utilizing your services. Is there any discussion of the potential for importation of CO2 for storage, or are you looking primarily at a localized model of this sort?
Oh, go ahead, Claire.
Yeah, then I'll let you jump in, sorry. In the near term, we're looking at using direct air capture or other engineered removals just because of this renewable energy opportunity. There's a really big opportunity to generate negative emissions with the renewable capacity that's basically deployable immediately. But we're also interested in point source capture and storage to help the country decarbonize in general. So there are emissions associated with geothermal energy. I think it's about 11 kilograms of CO2 per kilowatt hour, specifically in Kenya. It varies depending on upon the local conditions. So geothermal emissions aren't the same everywhere. But there's also a lot of agriculture and a growing industry that's growing. And there's a big textile industry growing, as well as a biogas plant that we've been talking to. So yeah, while our kind of near-term go-to-market strategy is to partner with DAC and serve the voluntary offset market, we're interested in point source emissions, and importation, I think, is probably a longer term plan, but there's definitely an opportunity for it that we've started to kind of consider because Kenya is on the coast. And so there's at some point going to be kind of a global network of CO2 that's transported and shipped around the world, I'm sure. But that would probably be longer term. And maybe James has thought about it more than I have, so I'll let you chime in.
Yeah, I think, well, it's a good question. If you think about comparative advantage, if we do buy that durable storage is going to be a critical part of maintaining or reaching the 2050 and beyond climate goals, then we actually have to be thinking about what are the comparative advantages of different sites. And I think it's fair to say, as Claire has alluded, that if you think about where the Great Rift is and the infrastructure investments that will be needed, it's still a ways out to actually do the piping of CO2 from the coast to there. And I think that argues for, firstly, direct air capture, just as a pure, positive. But secondly, if you think about, the big imperative for countries in sub-Saharan Africa, which have large labor forces and are huge exporters of many industrial raw materials, part of what we may be saying is for the hard to abate sectors, rather than move the CO2 from places where it's being generated and captured to this region, we may want to move those activities to where the sinks are, because that's where the labor is, that's where the clean energy is. It's actually a faster way to decarbonize the planet than keep everything exactly where it is and deal with some of the other asymmetries that we see. Because in some ways, if you think systemically, we're saying that at the same time as we are having this carbon problem, we also have an energy challenge in terms of, countries that need to be dependent on fossil fuels, given their geography and so on. And finally, also a migration problem in terms of where the jobs are versus where the young people are. And actually shifting where some of these hubs are allows us to create balance while actually doing good for the planet.
Great, thanks for that. And looking at your list, by the way, of direct air capture companies, I want to give a shout out to Octavia Carbon in Kenya. We're planning to do, this is a Kenyan-based DAC company, and we're planning to do a webinar in a few weeks on Octavia's efforts. So it's an interesting sort of potential partnership here. So
the former colleague.
Yeah, of course. So there are a lot of questions in the chat box, so I'm going to go right there at this point because I think this will occupy the rest of our time. First question. The World Bank says that the electrification rate in Kenya was 62.7% in 2020. How do we think about using clean power for DAC and CDR in places where household energy access is not yet 100%?
I think there's a number of misunderstandings of how the energy markets work and how energy access actually works in the global south embedded. It's a well-intended question, but one of the challenges is distribution and transmission, particularly for outlying low-income populations, is a really, really tough business to make work. In other words, you need people to have an income that allows them to pay the light bill for the grid that you're going to build to reach them. Or more likely, what you're going to do and what Kenya is doing and why its actual electrification rate is surging relative to its neighbors is really double down on off-grid solutions and mini grids and so on. So decentralized, delocalized, so that you're actually serving people with energy where they are. But if we look at the grid, Kenya's grid right now is about 3 gigawatts. That's trivial. It has hundreds of gigawatts of renewable potential, over 10 gigawatts of untapped geothermal, many times that in wind, some of the highest quality terrestrial wind assets in the world that are barely tapped. And of course, we're on the equator and we're a relatively dry country. Do the math on what it means for our solar potential. The reason why this is not being developed is not a supply question, it's a demand question. Because ultimately, to underwrite energy projects, you need bankable demand that will actually cover the bills. And what the challenge has been is historically people are focused on lending African countries money to build up energy supply. What that's meant is overpriced power on the grids, which make these countries uncompetitive, and limit access to power. What you actually need is to really focus on bringing large-scale demand, which actually then creates a business case for building out the supply. And as the supply goes up, well, two things are happening when you build up demand. One is you're creating jobs in industry, which actually puts income into people's pockets and allows them to pay for power in their own homes. But secondly, once you're scaling up your grid, because of that kind of anchor consumer or anchor set of consumers, there's a lot more available for regular household use. And so that's the key here. It's exactly getting affordable energy access done that actually makes these types of things and green hydrogen and green steel and so on really interesting use cases for countries that have massive quantities of untapped renewable potential.
Okay, thanks for that. Anything to add, Claire?
No, I think that James is the perfect person to speak on that topic, so he covered it.
Okay, next question. Exciting proposals, but do you really aim to sell in the voluntary offset market? This would mean all your effort results in no reduction in atmospheric CO2 because it legitimates continued emissions at the other side of the offset. What say you?
Yeah, I think that this is kind of a common thought in the carbon removal, I guess, at this point, is the concern that what I'm reading between the lines is that there's a concern that scaling and kind of implementing carbon removal projects just sort of facilitates the continued emissions scenarios. But importantly, the IPCC report was clear that even if we were at net zero tomorrow or at zero emissions tomorrow, we would still need massive amounts of carbon removal to reach our climate goals. So 10 gigatons of carbon per year, which is a huge amount, a huge number. I think we've all seen that figure from the IPCC. So we need removals even if we reduce to zero. So that being said, I personally don't think that removals today would incentivize the continued use of fossil fuels, because a removal is different than an offset, such that a removal is a net zero. An offset is a net 1. So we're not talking about offsets, just removals. And the reason that we're doing this right now today is because it's going to take a long time, especially for DAC companies, to scale to the numbers that we need, that 10 gigatons. But if we don't start now, we won't get there by 2050. So just to be clear, we still absolutely need to prioritize globally to a zero emissions world. We need to decarbonize, and there's absolutely no one in the carbon removal industry is suggesting that this is comes instead of decarbonizing, but rather in addition to, and we need to start now. And yeah, just as my personal opinion is that I think, we live in a capitalist economy, at least in the US, and that removing a drop in the bucket of what we're emitting, I don't think is going to incentivize the continued emissions. We don't really need to incentivize continued emissions. They're already quite heavily incentivized because of the demand for fossil fuel energy and because of government subsidies. And so a lot of things need to shift to incentivize decarbonization, but I don't really think that the option to remove is one of them, considering the supply of removals is so tiny at the moment. Hopefully that helps.
Anything to add?
If I may add,
Yeah.
My sense is we're at an early stage in what needs to be an effective carbon market if we're really going to address this issue. And part of the goal here is to raise the price of actually, have people pay the actual price of removing the carbon that they emit. And frankly, from that perspective, the higher that price is, the better, because the bigger the incentive for people on the other side of the ledger, and the greater the disincentive to emitting. In a sense, I don't know that we can get to where we need to get to by regulatory fiat alone, unless we start to introduce a set of incentives for both the right kinds of activities and disincentives for the wrong kinds of activities. And frankly, linking those markets makes sense. So I think everything that Claire said is spot on. In a dream world, you probably want to see the prices for carbon emissions getting to the hundreds of dollars in the not so distant future. And similarly, the value that's available, the value pool that's available for removing that same ton of carbon, getting up to that same price point. That's probably where we start to really realign systems and get people to actually internalize the costs that they're currently externalizing to everyone else.
Okay, thanks for that. Next question. Could you speak to the community support for projects like this? And how are you educating communities about both the benefits and potential risks associated with such projects? I don't know who wants to kick off on that.
Would you like me to go? Oh, go ahead, please.
Well, I'll let you jump in, but I'll just say, I can only speak to what we're doing at Cella in particular, which is that, community engagement is extremely important for any carbon removal project anywhere, or really any industrial project that's happening anywhere. So it's definitely something that needs to be prioritized no matter where you are. But kind of newer work on community engagement and done by groups like Carbon Direct and Carbon 180 really emphasize the importance of giving the community decision power, and actually not just educating them and making sure that they're aware of what's happening and kind of letting them know, but really including them in the design of how it happens. So community engagement was really the first thing that we started at Cella before we even really incorporated. My co-founder, Corey, is located in Nairobi, and he's made several trips up to our sites and has engaged with local groups such as the Maasai organization, as well as community organizers that are involved in a variety of different groups and stakeholders, and listened to what their concerns have been. And we've incorporated them into our experimental design. So I guess one example of that is There's been a lot of problems historically in Kenya, specifically surrounding geothermal and problems that it's caused for community groups, whether that's displacement because of land need or pollution of surface waters because of geothermal brine waste. And that's something that has been a little bit of a concern for the community groups that we've engaged with. Specifically, when we mention that we're working with geothermal companies, I think that the red flags go up because of some past issues, particularly with surface water pollution from geothermal brine waste. So we've incorporated that into our pilot experimental design, where we'll be re-injecting geothermal brine waste along with our CO2 to serve a twofold purpose of disposing of the brine waste that could otherwise pollute surface water sources, as well as accelerating mineralization in the subsurface using that water. So not that we're like a shining example, because everyone's just learning about how to do this. But I think that just beyond educating people and helping them understand what's happening is really trying to find ways to change what you're doing and what your plan is, given feedback and requests from local groups about their concerns. So I don't know, we're just doing the best we can, but it's important everywhere. So yes, James, if you have anything.
Well, I'll say two things. Firstly, for a new technology startup working in a new country, you all have been pretty close to the gold standard for having this stuff front of mind. So, kudos to you for that. I think the one thing I'll add is I think there's an ongoing effort, and President Ruto of Kenya has been kind of upfront about this, around giving communities and societies on the continent a little bit of a different narrative around their role in the climate emergency. That speaks to some of this, right? So we tend to think about populations in the global south as kind of the hapless, helpless victims of climate change. And that's not a great place to be and to think about oneself as a person with agency in the world. And I think part of what's happening now with the recognition of the role that Africa in particular could play in balancing the global climate accounts, given its particular sets of assets, is a new narrative around, well, how do we get a new generation to think of themselves as a generation that actually fixes this problem, which is not a role, frankly, that many people are used to casting African communities in as global solution leaders. But if you actually do the math on the climate crisis, that's actually what they will have to be, and potentially uniquely positioned to be. And so there's one aspect of this that is about engaging communities about the effects of various technologies. But there's another around giving them agency around the fact that, what is this doing? Why is it being done? What is your role in it? How do you actually, take ownership of these technologies, these tools that are a relatively early stage in their development, such that, the example I use is you go to any deep sea oil rig today, you'll find one or two Scotsmen and women, mostly Scotsmen, just because of the nature of that industry. And that's because North Sea oil really pioneered a lot of deep sea oil drilling techniques. And as a result, lots of people from Scotland were early exposed to those techniques and took them around the world. You could imagine a future in which a whole range of new techniques around direct air capture, mineralization, and so forth are being pioneered in this space. And everywhere you turn elsewhere in the world, you find a few Kenyans, grizzled Kenyan men and women, working all over the world, building out this industry and talking about how they used to do it back in Naivasha.
All right, thanks for that. Yeah, I like to hear that idea of a reflexive sort of process in terms of public engagement, right? I think it's one of the things that's going to prove critical to proceed equitably, and also to move these kind of projects along, right? I think that this effort to just educate and beat people into submission to accepting projects, right, has a long disgraceful sort of an unsuccessful history, right? So I'm really glad to hear the kind of the nature of this process, and hopefully it'll be a good model for multiplicity of projects throughout the world. The next question is, are the methods and standards of the monitoring, reporting, and verification that was mentioned publicly available?
I'm assuming you're talking about MRV for storage specifically, and
So.
And yeah, so there's a lot of publicly available information around monitoring and verification associated with carbon storage and basalt, mostly born out of the two pilots that have already been done. One of them was in Iceland and the other in the Pacific Northwest by the Pacific Northwest National Laboratory. So I guess given that context, it does depend on the injection technology that you're using. So a water dissolved method, which is the Iceland method, uses geochemical MRV, which involves sampling of reservoir fluids throughout the injection period and thereafter, whereas an injection of pure phase CO2 relies more so on geophysical monitoring technologies, pressure testing and seismic and everything. So at Cella, we're developing a novel and proprietary injection technology that at the moment has coincident novel and proprietary MRV. Hopefully at some point down the road, after we build our technology and our in-house expertise, we'll join a lot of the really great efforts that are being made to make the MRV public and really transparent. That's something that's a priority to us, but that's not available at the moment. But that being said, kind of, I guess, with the backdrop of what we just discussed around the opportunity here specifically is we're really trying to do our best to prioritize a technology transfer such that if geothermal companies or local companies that already have sites want to develop and monetize this opportunity themselves rather than relying on us or other folks to come in and do it, that we can make sure that our business model works out such that we can participate in technology transfer to really enable everyone to do this. I mean, it's a global problem and the solution goes beyond just a handful of companies that can do this. Like, so I guess to answer your question, not yet, but hopefully. Yeah.
All right. Okay, next question. So this is part and parcel of a lot of questions related to development projects, right? What are the implications of these CDR investments on development for the Kenyan people? How can this ensure benefits to all versus being centralized into few people? Maybe James, start with that.
So I think, so firstly, it's about recognizing that part of the journey here is moving away from the way that, people in the global south are typically engaged on this, which is the few owners of an asset are asked to concession it either, in their own right or on behalf of their country, and payments above and below the table proceed. I think one of the beauties of getting in on a nascent technology-driven industry is there's a whole bunch of pathways for value creation. Companies like Octavia and others begin to form up and you build a truly diverse ecosystem. And you move away from the models of the past. You look at a lot of the narratives around, for example, corruption and state capture are built around this idea of African countries as producers of undifferentiated natural resources that are very easy to capture into kind of various kinds of structures of extraction. When you build a complex industry, that's a lot harder to do. Everywhere in the world where you have a simple extractive industry, you have these dynamics. Everywhere in the world where you have a diverse economy with multiple streams of value, you see an increasing transition towards a focus on better governance. Kenya is already an example of this. It's got a relatively diversified economy, and as a result, while bad governance does pop up and corruption and misappropriation does crop up, it's less of an issue than, say, in a petrostate. And I think the increasing addition of new diverse streams or new diverse use cases for the country's natural bounty is part of that journey. So it's kind of a circular problem. It's not first solve corruption and then this. You look at the history of any country in the world, it is precisely that journey from basic primary commodity production and export and into more diversified, more complex industrial activity that actually forces the shift towards both better governance and better distribution of benefits.
Okay, thanks for that. Next question. Do you plan in situ mineralization as well as ex situ? I guess that'd be for Claire, or at least to start.
Yeah, so right now we're only planning to develop in situ mineralization. There's a lot of different companies that that work on ex situ, and it's both from a direct carbonation perspective with industrial waste, as well as, I guess, enhanced weathering can be lumped into ex situ, even though it's not really mineralization. But yeah, like we're the third in situ mineralization company in the world, and there's definitely a lot of innovations to be made despite the really groundbreaking and amazing work that's come out of Iceland over the past decade. The problem's just too big really for us to solve alone. So we're really just focused only on in situ mineralization, especially given the fact that while there's a lot of capacity for traditional geologic storage in the US in particular, many places around the world don't have that capacity and really rely super heavily on carbon storage and basalt and in situ mineralization to be developed technologically. So, so we're only doing in situ.
Next question. If this partnership was replicated in the United States, do you envision issues permitting both geothermal activity and storage in the same location? You looked into that at all, Claire?
I don't know about the permitting process pertaining to geothermal development in the US, but there is a very rigorous and somewhat infamous permitting process related to subsurface CO2 injection in the United States. I think that many of us are probably aware. So yeah, I guess to answer your question, I don't quite know about the complications associated specifically with co-locating them, but I can't really imagine that it would be any more complicated than the process of just permitting a CO2 injection well anywhere, because that's really quite complicated. In fact, it might be easier in a geothermal reservoir because there's much more known about the subsurface, and really a huge heavy lift for permitting in the US is you need to have an extremely strong understanding of your reservoir, which is a very expensive thing to do, which kind of excludes small companies and startups from participating in carbon storage in the US, because I think the costs associated with preparing and submitting a Class 6 permit application are estimated to be close to millions of dollars, just if you don't already have a reservoir that's very well characterized. And so that really does kind of shift the role of doing carbon storage in the US onto oil and gas companies, because they have a lot of information about the subsurface and they have the money to kind of underwrite the development of this stuff. But yeah, I'm not quite sure about permitting associated with geothermal here.
There's a two-part question. One part may be a legal question that that you may not want to engage with, but we'll see. What are the liability risk differences between mineralization and traditional sedimentary sequestration? And then the second part is, does mineralization also introduce risks of increased seismicity and subsidence?
So I guess I'll answer the second part first, which is that injection of anything into the subsurface does have risks of induced seismicity, and just those are things that need to be managed with really rigorous technical and scientific knowledge and people on your team and experts to work on this stuff. I mean, that's across the board with anything that you're doing in the subsurface, but specifically with injecting of CO2, we've become really good at managing those risks in the context of oil and gas. And additionally, with geothermal activity, I mean, re-injection of water is a very common practice thing that is done to recharge the reservoir. I mean, geothermal production depends on steam coming up from the subsurface, so you need to re-inject water to sort of recharge that reservoir. And it's something that engineers and really know how to do very well. But in terms of the liability risk with traditional sequestration, I just like to preface by saying traditional sedimentary sequestration is really quite safe. I mean, it's something that's been done for decades, and we know really well how to make sure CO2 that we inject stays down there and that it doesn't leak. So it's not inherently risky or dangerous operation. But there is also a lot of interesting kind of discussion coming up in the carbon capture and storage space around incorporating the costs of long-term liability and long-term monitoring into the price that you pay for offsets right now. And this is something that's not decided or set in stone, but it's probably something that will take shape over the next couple of years as insurance and all that stuff starts to be incorporated into CDR and CCS projects. So just as an aside, there was a really interesting paper that came from a colleague of mine at Penn State around actually pricing the value of mineralization as a function of reduced liability risk of traditional sedimentary sequestration. So if you think about it as mineralization equals avoided leakage risk, then the value of mineralization is a function of the theoretical percent leakage. So in a, for example, 1% leakage scenario where 1% of your CO2 leaks, there's actually costs associated with that for remediating waters that have been damaged, paying back tax credits that have been earned, and those things can be quantified and put into an academic or into an economic model that actually can put a number on what the liability costs are. So that's something that's kind of interesting to me and translates directly to the value of kind of these non-traditional, newer technology, carbon storage that are being developed at the moment. So yeah, I guess, and just one last thing I'll say is that there is kind of a preference currently, at least in the voluntary carbon market, for mineralization. I mean, it's nice to think that it's turned to stone and you get there's a perception that is definitely founded in truth, but there's a value placed on the durability and the perception of relatively more durability with mineralization as opposed to traditional sequestration. So it's part of the reason why we're interested in serving the voluntary market, is because there's a clear preference for this type of storage in particular. That might change over time, though. We'll see.
Okay, thanks for that. Next question. This may be for both of you. What are the relative costs of energy in Kenya expected to be in terms of powering DAC versus those in Western countries?
It's a layered question. I think current prevailing prices on the Kenyan grid are upwards of between $18 and $25 a megawatt hour, which is, well, I used to say is much higher than you find elsewhere, but with the disruptions to global energy markets, it's kind of middle of the road these days, but may not remain that way for a long time. The reason the power is so expensive is that there's so little of it, and also importantly, the average consumer on the grid has to pay for the curtailed power that has been built out and is not being used. Goes back to my earlier point around the fact that what you find in a lot of African countries is that the buildup of energy supply onto the grid has outrun industrial demand and has created this demand trap. The power is expensive, so industry doesn't come. Because industry doesn't come, there's a lot of surplus power. That power still has to be paid for because of take or pay agreements. And you can, so you're stuck. It's expensive because no one has come, and so on and so forth. When you look at it, you should be able to, in absolute terms, if you could get past legacy issues, you should be able to approach some of the lowest prices. You should be able to approach 4 or 5, maybe as low as $3 a megawatt hour in solar, wind, geothermal in terms of blended tariffs. Lake Turkana Wind, which is a terrestrial wind project in Kenya near one of the key geothermal zones, is the second best performing terrestrial wind project in the world in terms of capacity factors. Typical wind projects at around 45% capacity factor. This operates at 66. It's almost baseload grade, and that's next to geothermal and next to very high quality solar. So the underlying potential is there and it's high. In addition, when you're thinking about various DAC technologies, as Claire pointed out, many of them use heat. And there's a lot of waste heat coming off of just the very large geothermal sector that exists, and that heat is currently unpriced. And so any value you offer there is just gravy on top. So energy competitiveness probably starts with leaning on heat in the early going, as you begin to then unlock probably purpose-built new renewables that begin to approach global minima for the various technologies as you get to scale.
Okay, thanks for that. Next question, maybe our final question. How do earthquakes from the Somalian plate play into the risk for storage?
Yeah, so that's kind of one of the nice things about mineralization and just geochemical storage in general compared to traditional storage is that there's, I mean, risks of this stuff happening, not everywhere, but it's real, especially being in a tectonically active region. But with mineralization specifically, like there's really no feasible way for the CO2 to be liberated with mechanical shaking that would be induced by an earthquake or fracturing. The only way for it to be liberated is if the calcites and the carbonate minerals precipitated underground are heated to 900 plus degrees Celsius, which of course could happen if a volcano were to erupt underneath them. But the same risks apply elsewhere where this is being done. I mean, in any sort of volcanically active region where there are really favorable rocks for this, like young and fresh basalts, that the heating is the only risk, not so much earthquakes. But we as geologists have gotten really good at trying to at understanding and predicting when and where this stuff's going to happen. So obviously that kind of plays into site selection, but yeah.
Okay. All right. We've got time for one more, I believe. This probably would be for James primarily. What kind of policy should the government of Kenya prioritize in order to bring DAC developers to Kenya? Sure, that's something you've thought about.
Not only have we thought about it, but the government is actually actively thinking about this. And then the workshop that Claire mentioned next week with several cabinet ministers and so on is really meant to look at Kenya as a destination for carbon removal of all kinds, nature-based, hybrid technologies such as biochar and the like, as well as heavily engineered technologies such as DAC and mineralization. And I think one of the key things that Kenya wants to come to the table with is a combination of regulatory agility, recognizing that in the absence of a prior kind of incumbent set of industries, it can really optimize its regulations for these emerging new industries of the future. There's something there around speed. There's also something there around the point that I made about shifting from a very supply-oriented way of thinking about the energy system to a demand-oriented model that's really around asking, what are those energy-hungry, climate-smart applications of the future, and what does it take to attract them to the country? And that speaks to the critical thing that the country is now beginning to orient around, which is a new narrative. Kenya's president has actually articulated that he anticipates positive carbon impact to be one of Kenya's biggest exports in the next 2 to 3 years, and its fastest growing export. So actually beginning to do something that few countries have ever done, which is how do you make being a climate good actor kind of a core to your economic strategy, your public marketing, and so on, which allows companies that are thinking about whether to stay in the US and deal with some of the permitting issues and so on that go with the benefits of accessing the IRA subsidies and so on, versus, well, actually the underlying kind of physical properties might be better for certain technologies in Kenya. And there's hopefully a greater bias to speed in terms of proof of concept. And finally, greater headroom. in terms of how much any one of these use cases can scale without coming at the expense of other decarbonization activity. So that's the pitch and the story. There's aspects there of how you position, but a lot of this eventually boils down to shifting mindsets around the world, and getting people to really think about these global problems as having global solutions, and finding the best possible sites and the best possible blend of attributes to do this work, versus kind of saying, well, these kinds of things have never been done in this corner of the world and never will be. Let's do them over here, even though it's better to do them in the place that, you know, is more geologically and naturally suited.
All right. We are going to end with that. We are at the top of the hour. As I expected, this has been a fascinating discussion, great questions. I'd like to once again thank our guests, James Mwangi and Claire Nelson, for discussing this project and the kind of broader vision of Kenya in the role of carbon removal. And as I said, stay tuned. In a few weeks, we'll focus on the other end of the equation, a direct air capture company that is being built from the ground up in Kenya. And I hope, as always, you can audience members will join us in the series. So thank you very much, everyone. Have a great rest of your day.
Thank you.
Thanks, everyone.